Alright, welcome back to the stream. This is going to be another stream that's somewhat self-contained, as in not just a sprawling bit of minutia buried inside of this robotic camera that we've been working on. This one's actually going to be working toward a series of videos I'm putting together about, well, sort of an educational series on how USB works, but I thought I would focus on individual devices on each episode and try to approach, how does this device, USB? And so the first episode might be like, mouse, how does it USB? Here's cat. I don't think we'll ever know how cat's USB. But there we have him. Oh, is he gonna jump onto the rack? Cool, we are receiving bits on the YouTube. Looks like Twitch should be up too. Oh, did we lose him across the jump? Tuke's inspecting what's left of my coffee this morning. Alright, well, welcome to the stream. So, yeah, we're just going to be trying to keep track of this cat, I guess, but not actually working on that on this stream. This stream is going to be basically collecting footage and ideas that go toward the first episode of this USB educational series. So I thought it would be useful to start from a USB mouse as a way of both introducing a concrete device and introducing some core USB concepts. And I thought it would also be an interesting thing to look at a concrete mouse that came out, you know, right when USB was first being adopted by consumers, because I think that would illustrate some of the design decisions that went into USB. I think it's maybe confusing to approach USB when you're used to, say, Ethernet or, you know, I think a lot of people at the time even approached USB with some of the ideas in Firewire, for example, and they were really confused with like why USB has this weird topology. And I think if you look at USB from the perspective of how much silicon it actually costs to implement versus the other alternatives, then it's pretty clear why it was done, and that was, you know, kind of a way of doing the interconnect on the cheap, if you will, but it was also a way of actually enabling something to come in and replace the, you know, the interconnects of the day were, you know, parallel and serial and PS2, and you had to keep the hardware cost low and have a fairly simple entry point to replace technology like that. Where is Tuco? I've lost track of Tuco in real life and trying to steer the robot here. So yeah, and a mouse is an interesting starting point because, you know, while you can't... Where is Tuco? Oh, there he is. Yeah, you can't learn about the entire USB stack just from mice, but I think if you start with a mouse and then perhaps add like storage and then audio, I mean, maybe that's a bit too steep of a difficulty ramp because each of those gets more complex pretty rapidly, but you know, I can imagine a fairly small set of USB device classes where if you understand those, you understand pretty much most of what there is for USB to offer. And I think that would probably include like mouse and storage and either video or audio. I've been wanting to do something educational on USB for a while, so yeah, this is partly me just trying to give myself a kick in the pants and do it, and partly, I think partly it's that I'm finally realizing that I should just, like, kind of how I should focus it. And I think this thing where I try to focus it on a single episode for a single device, but then try to use that also to tell an interesting narrative about how the protocol was designed, or how to use it, or how to take it apart along the way. And so with with the mouse, that's also an opportunity to talk about, HID, of course, but it's also an opportunity to talk about USB and then how it compares to the other standards of its day, and then how it was extended later on. Or maybe not jump into the extension later already, because that's like making the episode much larger in scope potentially, but about how they left the door open for extension. So to that end, I'm actually pretty curious whether these devices are low speed or full speed. That would be an interesting thing to know before I really plan the route of the episode. So maybe, let's see, I've got a couple of these mice here, and we could open it, we could also plug it in. It might be nice to, I'm just thinking about planning ahead for photography's sake. We might get the most options here if I try to keep one of them relatively pristine in case I need exterior shots later. And then with one of them, I do some exterior shots now, and then I get some USB analyzer footage so we can see what it looks like in there. And then I take it apart and document that as best I can. And then depending on what kind of microcontroller is in there, I'm also curious to know how deep we feel like going with firmware potentially. Oh yeah, this is just Tuco's usual post-litter box routine, actually. He likes to clean out his paws, and he'll just like wail on whatever's nearby. And I've tried making this nicer. Like right now, I mean, he's eventually going to tear up that piece of furniture. He's already kind of messed up the paint job, and so it's like I don't really know what to do. I tried putting a piece of wood over top of it, but he didn't like the wood and he just avoided it. I've tried, well, not here, but one of his previous litter box locations, I gave him a carpet square that I hoped would be in a good location for him to clean his paws on, but he didn't seem to like that. He liked the hard surfaces. So I don't know, he's a weird cat. I don't entirely understand what he likes yet. Yeah, and USB is an interesting protocol. Like there's, I would also certainly want to have an episode that talks about USB serial, and that would be an opportunity to talk about, well, how does USB serial actually work? But then also, well, why do you see so many people using USB serial, and how do people tend to use that as a way of kind of skipping past the complexities that you'd otherwise see in USB? And I think originally you saw that as a path that was put out there for manufacturers of legacy devices, like here you can just stick this adapter on and use it with USB. But then of course the proliferation of devices that were designed for that in the first place, because full strength USB was just too complicated for quite a while. And it still is complicated. A lot of people use USB to serial adapters instead of designing their own USB protocols because it is still relatively complicated. So alright, I think that's maybe enough introing. Let's do a little photography and then a little bit of USB analysis. Oh, sheet metal. Maybe. Yeah, I don't know if sheet metal, like I've been hoping to give him something softer instead of something harder, but I don't know, maybe you want something hard. Oh, cool. It's nice to see 16 of you on Twitch. Usually we have not a lot of folks on Twitch and more folks on YouTube, so it's nice to see a bit more of a balance sometimes. So, hi, this is the front view. Let's actually have the above view, though. As usual, I'm a slacker who doesn't put cards in her camera before starting the stream. Back on auto exposure. Oh, and more Velcro. Oh man, these things sound very tactile. I'm going to focus way too much on how things sound if I do this with my headphones on. Usually I don't wear headphones, mostly for this reason. It's just super distracting to be monitoring my own audio. More so with talking, like I kind of lose my train of thought, but even just the details and the sound effects are mesmerizing. Yeah, so which of these should we take apart? I think the dark blue one is slightly dirtier. They're both in pretty good condition. Oh yeah, I also had a couple of other mice here. I'm not quite sure how these fit in, but I thought it would be good to show the previous interfaces from around the same time period. So we have PS2, which this is not a time period PS2 mouse. This is a more modern PS2 mouse, but as you can see, they're optical. But that would still be, you know, not too far off from what you would have had then, and these were cheap. And then this is a more vintage Microsoft serial mouse. I remember having one of these. I bet my dad still has one of these somewhere. Is this gonna have a dirty ball? Slightly. Wow, it looks like an old soccer ball or something. Or a basketball. Like it has a slightly dried out surface. That's pretty weird. It doesn't feel terrible. I think it would still work. So yeah, man, maybe I'll even want to introduce just briefly, optical and roller mouse technology. I don't want it to be like a primer on how mice work, though. I want it to be more about USB. So I'll probably really quickly say that these mice are all designed to measure relative motion, and they originally did it with a ball, and now they do it with optical sensors. And that's probably about as much as I need to say about that. Yeah, these certainly collect the gunk. Good old left and right mouse button, no scroll, no middle button. But these still feel pretty good. The serial mouse in particular I thought would be an interesting point because this is running over an interface that is completely not at all designed for what it's doing. And so it's just parasitically slurping a little bit of power off of the signal lines, and it's using a really simple serial-based packet format that doesn't include any way to identify the mouse, really. And so there's this sort of entire family of de facto standards that grew up around that, and their own classes of Windows and DOS mouse drivers that support those protocols. And then it got a little bit more standardized with PS2, but there were still just a lot of strange non-standard extensions to support, scroll wheels, for example. Menere is asking what all the mises are for. They're basically visual aids and examples for a video I'm working on about how USB works. And I wanted to do an episode that focuses on kind of early USB adoption and how the USB mouse was designed, because I see that as a really important milestone in USB adoption. So I'll probably want to take apart these two mice as examples for pre-USB technology to compare this to. But I want to focus, at least on this stream, especially on these mice. And I got these because this is what I remember as the first USB mouse that I really just came across in daily life. I remember seeing these at school, and before that I was used to mice either being serial or PS2 or ADB on Mac OS. And this was the first consumer application of USB I remember seeing, was the iMac with its USB mouse and keyboard. So let's take one of these out. I think let's take the light blue one out. Oh, these cables are pretty. Oh, and they feel terrible. by the way. The cable is actually not as bad as I thought. I've had old Apple technology from this era where the cable itself was all gummy and gross. And this one looks a bit gross, but doesn't actually feel that bad. It's just kind of yellowed. The transparent stuff was really a fad at this time, and it looks nice. It just doesn't look nice for very long. So I think as soon as people started seeing like the old kind of yellowed stuff around, it was harder to get people excited about the look. James says that they expect that the topology of USB came partly from Apple and ADB. Really? What makes you say that? Are you just saying that that's like what your expectation would be based on the consumer technology trends, or does the technology seem similar to you? I almost feel like I should be handling this thing with rubber gloves. Where's Tuco? I was just hearing him. Oh, I think I'm missing context again. Manta Ray said, I would like to know that actually, but I've already forgotten what that was in reference to. Where is my cat? Oh! Oh, he's behind that curtain, which is why if you go over to this stream... So by the way, there are maybe 3 places you're hearing my voice out of. There's the twitch.tv/scanlime, twitch.tv/tucoflyer, and if you go to YouTube/melizabethscott or search for scanlime on YouTube, you'll find me there too. Oh, there he is. Oh, which video feed? Whoa, that's old. That's apparently the video grabber being crashed. Let's go over to this one. He's standing right there behind the chat now. Wearing gloves because it's sticky and because my skin is dry. Oh, Tuco, don't bite that. I'm sure it's gross. You don't need to be licking 1990s plastic. I don't understand the analogy that James is making. So James says, let's see. Sorry, I'm a little behind. James says, I expect the topology of USB came partly from Apple and ADB. In PS2, you have 2 ports on the back for keyboard and mouse, and in ADB, you have a cable from the computer to the keyboard and one from the keyboard to the mouse. Electrically, so there isn't a correspondence there, really. I don't. So USB doesn't let you daisy chain stuff like that. ADB lets you just kind of daisy chain buses. I forget whether that was passive or whether there was like a command forwarding kind of mechanism there. But each computer or like each device had like an input and a through port in that case. USB doesn't work like that at all. Apple made it kind of seem like that with their original keyboards and with their later wired ones because they included a hub in the keyboard. So that might actually be an interesting point to include in the video because that isn't implemented like ADB at all. It's implemented completely differently. They just made it look similar from a consumer point of view. Oh, okay, yeah, cool. I saw Monterey's clarification that the thing that they wanted to know was about how USB came up and its adoption. Yeah. Yeah, well, I think it might be interesting to see, like, I'm still planning out that episode, but this stream might be about how this particular device fits into that concept. And then there was a question about date codes. And, oh yeah, and then Piotr saying it's very distracting when the audio has a delay for monitoring. Yeah, for sure. I've tried to keep that really low latency here, but it does exist. Oh man, this holographic backing is really trippy and really 90s. Where is the year? I would expect this to be 98, 99, 2000, something in that range. What? So, and then Emily's bringing up that some PS2 keyboards had a socket for a PS2 mouse. Yeah, that existed, it just wasn't especially common or especially well supported across motherboards. If I remember right, that was a feature in the original PS2, but not a feature that a lot of PS2 clones ended up copying. And then... But the PS2 stuff, that was daisy-chained, much like ADB. That was not a hub the same way USB hubs work. Yeah, I guess I need an episode on USB hubs, and maybe... I don't know whether to do that before or after the episode on USB keyboards now, because it seems like there's some confusion around both. USB is a point-to-point link like Ethernet. I mean, like, you know, the electrical layer of Ethernet. And, I mean, but that's a bad analogy if you're going to talk about hubs, because Ethernet hubs and USB hubs are very, very different. I guess I'm just trying to say that you need a separate physical link. You don't share the same, you know, it's not like a party line where you share the same twisted pair. And it's not a daisy chain system. It's an actual star topology, but it also isn't like an Ethernet switch where you're storing and forwarding packets. It's more like the packet includes a little bit of a time window in which you can establish a switched connection, and then the rest of the packet flows through the switched connection. That's definitely something to talk about in a whole episode, probably, like how USB hubs actually work. Electron Ash says they believe USB was co-created by companies like Intel, Microsoft, and Nortel. And yeah, I forget the full list, but Intel and Microsoft were two of the big ones, but it was a long list of companies that had a consortium and still have a USB interface consortium. So yeah, I don't know which of these is a date code. I'm just going to assemble, or unassemble, I'm going to take apart one of these after we play with it a little bit on camera. Emily wonders if you could make a gigabit hub. Probably not. I mean, it wouldn't for sure be as simple as something like a 10-base-T hub, because you'd still need like equalization for each of those individual links. You'd need, I mean, I'm not an expert on any of the Ethernet PHYs, and I only know just a tiny bit about gigabit, but, and you're asking about 10 gig or gig? Just gig, okay. This is such a strange device. was kind of curious if there would be any test points for programming in here. I don't know if these things are going to have replaceable firmware or not. Being a relatively early device, it's possible that they don't have just a completely specialized chip and they might be using some kind of generic microcontroller, which is another reason I thought they might be interesting. Yeah, I think let's try turning this thing on and then taking it apart. I'm gonna keep the gloves because it's just kind of gross on the outside. This blue plastic is gone all sticky. I get to find out if these USB cables are actually connected to anything. Oh, I think I need to uncrash my video grabber. Alright, video grabber, how did you crash this much? It crashed doing what it loves, watching my cat. Keep pushing this button. Oh, that's different. Were you asleep? Yeah, this is what we're doing. $19.98. Design and criticism. Yeah, that's putting it mildly. Oh yeah, the shirt is like one of the outputs from, I think it was a collaboration between I think the actual image glitcher is something that, if I'm remembering right, Alison Parrish did, and then Darius Kazemi made a bot that posts these, and then either he or someone else made t-shirts out of a couple of them. So this is like an algorithmically glitched logo from the logo glitcher bot. You know, your friendly neighborhood logo glitcher. Is this working? Low speed. Did that work? Went into suspend right away. Oops, that was the wrong plug to pull. Let's maybe make this one shorter. Oh yeah, that's the thing, the logo glitcher. I wonder if this doesn't work. It's just going into suspend and staying there. Oh wait. Now it's resetting a bunch. Is there a bad connection in this cable? Huh. Maybe I should try the other one. This might be a problem with my setup here. My setup is not optimal, and I've got USB extensions and hubs all over the place, so let me try the other one, and if this one doesn't work either, I'll just make my setup less complicated. Oh, right. James reminds me that the... that's right. So ADB was daisy chained, but PS2 for mouse and keyboard was just swapping between two pins, like data and clock for keyboard and data and clock on PS2 or for mouse. Is that right? Oh yeah, George is asking if I might show how to use an analog discovery too. Yeah. What did you have in mind? I know we used that as an O-scope a while ago on some RFID stuff. I don't think I did anything complicated with it. I was just running the software it came with. This doesn't seem to do anything different. I'm just gonna, let's simplify this. How direct can I make this connection? It's possible this is some like old school USB that is not entirely spec compliant, or it's possible my setup is just completely not entirely spec compliant. Oh, you know what? I could try just, I don't have to use my demo machine as the endpoint here. I could use a Raspberry Pi as the endpoint. Let's try that just to make things maybe a little more simple or something. I don't know. It's right here. Okay, I think this is plugged into a Raspberry Pi, which should have USB HID drivers. Huh. I should try this without the USB analyzer. I'm going to try plugging this into the hub in my Apple keyboard right here. Oh, that works as a mouse. You know, I wonder... I don't remember using this analyzer in low speed mode. It's possible that it just doesn't do low speed. But I sure thought it did. Let's just double check. Yeah, I'm pretty sure this is supposed to handle low speed protocol. Yeah, it's possible there's something electrically a little weird about this mouse. Oh, no, I think this is my fault. I think I had something in this analyzer set up to force it to use a particular speed because I was doing something weird with this a while ago. I think this is my fault. Oh, no. I guess that's set back to auto detect. Can we force it to low? Is that going to help? That's interesting. On the keyboard here, I'm not even getting the speed detection. Well, I don't know why I'm not seeing it here. We could decode it on the oscilloscope, but that's going to be a lot less nice than looking at it here. We could also use a different kind of capture, like we could capture it on, like on the Raspberry Pi from Linux. Could run it through a VM. Let me just try to see if I can just test this with another low-speed device just to be sure the problem is where I think it is. This is a cheap generic keyboard, which is almost certainly low speed. Low speed. Also suspended. Why are we going into suspend? Well, that's an interesting data point then. The problem is definitely my test setup. That's the Raspberry Pi, also going into suspend. Let's reboot the Raspberry, maybe? Oh. Was this a cable problem? I wiggled the connection on the other cable here, the one I hadn't actually taken out this whole time, and I think that might have, that fixed it. Yay, it was a simple problem. Excuse me. So, that's my keyboard. Yay. Pardon the silly mistake. To clear this. Let's also put that back on auto. Not there. Okay, so now I'm going to plug the mouse in. Right. Now this was the one that was a little nicer looking. I'm going to put this one away and see if I can get the same result from the one that I'm about to take apart, because it's a little bit gross. What is going on here? This one's less happy. Is this just a cable problem too? Maybe. I wonder if there's a wire about dead in this cable. How about the other one? This one is better. Yeah, maybe the wire is bad. This might be one to take apart and do firmware stuff with it, since I could just replace the cable while I'm in there. But here's one that's working properly, so I can use it to move the mouse. It's kind of terrible, as you would expect. And there's one button. Oh, does the one button not even work? Oh, it does. I just have to click in the right spot. Okay. Oh yeah, this is terrible. Okay, let's stop that capture. Oh gosh, I can't use that mouse, yeah. That is pretty bad. So, all of these are the actual mouse input reports. You can see they have relative motion. So 0, 0 would indicate no motion, but you don't see those because it just refrains from sending out a packet in that case. Instead, you see 2 signed numbers for each axis, one for each axis. Oh yeah, and these are encoded in really small packets. So that's maybe a byte. You can have fields that are not byte aligned in HID, so it's possibly they're doing something small, but smaller than that. But that looks like 2 bytes, and then maybe some bits in that first value include the button. Yeah, low bit in the first byte. That is one of the simplest HID reports I've ever seen. And so there are a few different layers to talk about that this is built on. There's an electrical signaling layer which changes depending on what speed you're operating at. So here in low speed, it's a 1.5 megabit serial signal. If I remember right, it's so it isn't like Manchester encoded or anything like that. For the most part, the bits in the packet are the actual bits that go out, but in order to avoid imbalances caused by too many zeros or too many ones, there's a bit stuffing protocol, so that if there are too many bits in a row, you add an additional bit, and since that process is deterministic, you can just undo it on the receiver end. And it uses less additional bandwidth than like Manchester encoding the entire packet. So yeah, we could take this from the top and talk about the protocol, perhaps. I mean, this stream is mostly just going in for photos and ideas rather than like actually doing the USB education itself, but just for like a brief talk about what's going on. What you're seeing here, this is the layer where you are seeing individual USB transactions. So this set address is actually made up of a bunch of tokens that go across the bus back and forth, and there's sort of a handshake process. The set address itself is a setup transaction that gets sent out to endpoint 0, which is the the default control endpoint for doing stuff that's regulated by the USB class and device specifications, really. So setting up the device address, this tells the device instead of the default address 0, you're now address 28. So now you're going to start listening to packets that have address 28 in them, which becomes important when you start multiplexing the bus with hubs. So that corresponds with the device field here changing from 0 to 28 as soon as we finish that transaction. And then on address 28, we can start getting the descriptors. So we ask for the beginning of the device descriptor. In this case, that's, we can just ask for the entire thing because we know its size. If it were a variable size descriptor like the configuration descriptor, we would be asking for it in 2 pieces. So that's why we get 9 bytes and then 34 bytes. This is the header, and this is the whole thing. Here's the string descriptors. This first one is actually going to be the language table, I think. Actually, I don't know what these are off the top of my head. Oh, right. That's why these headers look weird. Because these are just getting the lengths of the strings. The OS isn't actually getting... It's just doing this in a weird order that was confusing me. So it's getting the device descriptor, it's getting the length of descriptor 2, the length... Oh, then it's getting all of descriptor 2. Okay. I just didn't expand that. So what actually is this? Is this the language table? Oh no, that's the model number, M4848. Logitech. That would explain why the internal, or that would like corroborate with the internal photos that I saw with a Logitech branded chip on this thing. So yeah, we're getting the descriptors. These strings are pointed to by the other descriptors. So for example, device descriptor, will this decode the device descriptor for us? These are the packets with the device descriptor in it. I think this tool will decode it though. Oh yeah. I think the view that I want that's slightly more useful in this situation is the USB prober, which just shows, like, from macOS's perspective, these are the descriptors that it's requested. So that's this M4848, which is the name of the device, apparently. So yeah, manufacturer is Logitech, product is M4848, but it has an Apple vendor ID and product ID. Clearly something that Logitech made for Apple. Max power is 26 milliamps. It's a HID boot protocol compatible device. Wow, is the only protocol it supports the boot protocol? Boot protocol is like a simplest possible, like, spherical cow model of an input device that you include just for booting up the computer and accessing BIOS menus and stuff. But this mouse might be simple enough that they just use the boot protocol all the time. The boot protocol is also simple enough that you don't actually have to specify the format because it's predefined. I think they do specify it here. I think you're supposed to specify this descriptor anyway, but like, you don't. A lot of drivers will work anyway because they'll use the, the standard one. So we have one button, which is a bit long. We have 7 padding bits. Yeah. And then X and Y, 1 byte each. So this is like a data type definition for the packets that the mouse sends back. This is saying you have one button, which is going to be a bit, which starts, least significant bit. Everything in USB is little endian. So that's size 1, count 1, has some flags. And then we have 7 things afterwards, which are all constant, and that's just padding it up to the next byte boundary. I don't know if this is required, but they probably do that at the very least for consistency. The spec might actually mandate this too. And then we have 2 things that are bytes, and they're each integers from -127 to +127, representing relative motion in the X and Y axes. So yeah, this is like the most simple USB mouse possible. I don't think you could define a mouse simpler than this and have it be spec compliant. Cool. So that information is being retrieved by these various get descriptor commands. Then after those descriptors, we have set configuration, which actually kind of tells the device to enter its powered on and active state. Before that, it's in the state that USB calls unconfigured, and the device is supposed to be in low power consumption and kind of having as much of itself disabled as possible. And then remote wake up is a feature that lets you kind of put the device to sleep, and then you can wake it up using this electrical signaling from the PC side. It looks like they're enabling that here. They did advertise support for it, right? But then the host is sending keep alive. Are these... I'm unfamiliar with what this notation in the analyzer actually means. This might be... So, I mean, I'll definitely, when I make a video on this, I'll definitely go at this from the oscilloscope angle too. I think this means that these are frames during which nothing's actually happening, but we're still talking to a device which is entered remote wake-up mode. That's interesting. I was always a little fuzzy on the spec for remote wake-up. I might have to reread that before I talk about it. It's a power management feature that lets you tell the device to stop expecting communication for a while, and then you don't have to talk to it for a while. But the analyzer here is like batching stuff together. What's actually going on is every millisecond the controller is polling, and it either asks, is there data to send on an input endpoint? If there were other endpoints, it would poll all the endpoints that might have some work to do. But in this case, the analyzer is collapsing a lot of that traffic for us to simplify this. Yeah, let's store everything. Let's see if that gets a more complete capture. That's a little more data. Cool. So usually low-speed USB involves a start-of-frame packet going out every millisecond. And so I think what it's doing is the host has put it into a mode where we're giving it a keep alive pulse instead of a start-of-frame packet. But yeah, I clearly need to reread the documentation for this area. So it's just telling us how many repeated frames were in the same state. So that was 682 milliseconds, which also equaled 682 of these keep alive states. Low-speed USB operates in 1 millisecond frames, as does full speed, which is 12 megabits. High speed, or 480 megabits, uses microframes, which are 1/8 of a millisecond. So here we had the transition from, from keep alive state to, so now we're actually configuring the device, and now we're actually pulling the endpoint. So here, every millisecond, is this every millisecond? No, every 10 milliseconds, because that's what the device asked for. Every 10 milliseconds, we send out one of these end tokens. So I think here, this must be ignoring start of frames. I must have the analyzer configured to filter out start of frame packets still. Oh, never mind. No, low-speed devices don't get start of frames. That's right. That's high speed and above. Low-speed devices aren't expected to do, they can't do isochronous. They aren't expected to need a frequent time reference. Yeah, we should look at this on the oscilloscope, but that'll be easier to do once I open the mouse. Let's open the one that's already got a busted cable. Yeah, the USB speed names were always pretty confusing, weren't they? Not very forward-looking, I guess. But I mean, that's, I don't know, it's easy to make fun of USB for that, but that's the thing that USB wasn't, it wasn't really ever intending to be the most extensible thing. It was intended to be inexpensive and capable of a wide range of existing use cases, and they did a pretty good job with that. Alright, well, we're finally getting this thing cracked open, and it isn't quite an hour into the stream. Or at least that's the plan. How does this come apart? It looks like there's screws under the translucent part there, and then the translucent part maybe is attached here and here. And up there and there. Spudgerize this thing. Oh, that definitely comes off. Oh, the color piece might actually come off relatively easily. Definitely unclipped right there pretty easily. I'm not being very gentle with this yet, but there it goes. This is like the piece of this that I'm least likely to want to keep. Look at all that grime. There's that 1990s shiny plastic aesthetic. Well, I've got an obvious way in now. I might have to use the right kind of screwdriver. That seems all right. Oh man, there's that Cypress chip. So the top case has nothing except dust bunnies. Bottom case has the strain relief, some mechanical gewgaws, and the circuit board. There's the mount for the 1 button. It actually pokes through the bottom. Got some flux goobers over here. That just looks like a PCB manufacturer marking down there. Like a little bit of ground fill up there, but not much going on. Really nice, thick, kind of matte looking white solder mask there. The 1 button, yeah. Weird mounting though, right? Like they angled the button through the board and then used a separate little circuit board just to hold the button on some header. Makes it really easy to replace the button with something else though. And then the wheel sensor consists of these 2 optical doodads. That's a single LED, and then I think a dual phototransistor. Oh, maybe it's 2 LEDs also. Because these are quadrature signals, so you would need two sensors spaced apart by half the distance between the slots in this wheel. And then you would notice them ticking 90 degrees out of phase. So there's the actual mouse wheel slot. Oh, I should start the microscope recorder and we can get some microscope shots. Right, I can start the microscope recorder from this desk, can't I? How many KVM switches do I have to tunnel through? Oh, I don't know if I can unlock this computer from this side. Oh, I'll be right back. It is unlocked. I think it's just not showing up on the monitor for some reason. Oh, because this is on the wrong channel. Is it? That's the right channel. James is saying they're used to seeing those optical mouse things as a single device with the encoder and, or like the emitter and the receiver. I've seen those on more modern mice, but I've also seen a lot that have just like separate LEDs and phototransistors for the sine and cosine channels too. I think it's just levels of integration. That's the microscope. Let's get a copy of that. Finest encoder wheels injection molded plastic can give you on the cheap. It actually seems alright. You can see some interesting patterns there in the middle, presumably from the hot plastic flowing. Oh yeah, now I'm just making ASMR videos. Okay. I'm gonna put this back in there so we can see how they all line up together. How does that fit? Got to carefully position the unibutton. How did the button fit in here actually? That was going through... Oh, right. So it fits on top like that. Can we see any of that when it's assembled? Get in through this side. Look at the colorful fluff around the wheels. So the roller rolls along the mouse ball. This thing rolls in its little bearings, and then the slots go past 2 rows of detectors here, which are still a little hard to see. The one closest to us is the light emitter. I don't know if it's 1 or 2 LEDs. It might just be a single LED. But it also looks like it might be that that right pin is a common that holds 2 LED dice that are stacked vertically. And then there's like a bond wire going down to the middle pin, and then a bond wire going left to the left pin. That view might be better. Oh. So the receiver is opaque. It's acting as an infrared filter, but it means we can't see inside as readily. It's also just kind of covered in fuzz. That fuzz is weird. Oh my gosh, is that tin whisker fuzz? It looks like it's metal corrosion of some sort, at least. You can see some branching structure. I don't know if those are tin whiskers, but it might be some kind of metal crystal growth. I want to get a closer look at that. So let's look at both the transmitter and the receiver here, now that we've got this thing out. It's a little hard to get access to both of them with the wheel there. So first, let's look at this one. It's a good view of the bond wires. Kind of hard to see what's going on in there because the surface isn't really smooth. There's a little lens. Oh, and some of the same corrosion on these leads. Wow. Makes me even more happy I'm wearing these rubber gloves. I mean, don't you have nightmares about this stuff? That is creepy. I kind of can't handle how creepy that is. Wow, I wonder if they're all like this. Again, this is the one that didn't work, so like maybe this is the reason why it doesn't work. My first guess was the cable, but it certainly could be corrosion all over the place. I kind of want to test whether this stuff is conductive. Vice. Ugh, this stuff is so creepy. Yeah, it just looks like kind of a black oxidation from far away. You can't really tell that it's that furry. Not furry in a good way. Furry in a I'm going to short out all your electronics way. Saying that. It needs more light. Somewhere I've got switches that give me light. I really need a better lens for this. I'd probably get interesting photos doing this in my optical microscope. Okay, that might be enough to get a multimeter probe in the shot. looks like they're conductive. It's kind of hard to tell. I'm gonna try touching something I can see a little better. Like these over here. That's not quite what I meant to do. No beep though. It doesn't seem like that very outer layer is conductive, but it's hard to tell for sure. I figured if it was conductive, I might be able to get a beep without actually putting any pressure on there, but just brushing it against them, but I haven't seen that yet. But that is worrying. All right. Oh, that's an interesting strategy, or interesting hypothesis. James thinks it looks like a bunch of tiny magnetic particles. Maybe. I guess that could be magnetism. I assumed it was a chemical process, but maybe. Okay, let's take a closer look at the chip on here. So let's go ahead and take the cable out. This is using the standard USB cable colors, by the way. There's shield, which you can tell because it's just like a different kind of wire. In this case, it's like uninsulated wire that's been wrapped onto the shield, and then, or maybe that's even just heat shrink over the shield itself and then crimped. I think that's actually what it is. So that's the shield wire, which you don't often see in low-speed USB devices. That's a corner that is often cut, but in this case, they included the shield wire. And you can see the shield through the plastic. And then black and red are ground and power, and then white and green are the data. I think white is D- and green is D+, although I could certainly be getting those backwards. I usually look it up if I'm doing anything serious. Oh, there's another Logitech logo that I missed earlier. This frivolous little circuit board that just holds the clicky switch. That's great. That's the crystal. Is it going to be 6 megahertz? I think it's 6. Usually these are 6 for USB protocol reasons. And then the resistors here, some of these are going to be just decoupling capacitors. Some of these look like pull-up resistors for the photodiodes, or phototransistors rather. And then, current limiting resistors for the infrared LEDs. So these are going to be LEDs that just transmit a continuous infrared signal, and then it's blocked by the windows in the rotating discs, and then we see pulses that arrive sequentially at the 2 detectors in each of these packages. So I would have assumed this would be some variant of the original Cypress Easy USB microcontroller, but I don't recognize these markings. Well, I'll have to look these up. I think I can take off the gloves. Excuse me. Jimbo says that the stuff on the wires looks like a dead black mold. Yeah, that's especially creepy. I don't want to imagine that they're mold. Oh, and then Brian is asking what my parents do for a living, or what they used to do. Yeah, they're both retired from the job that they spent the most time doing. Actually, both of my parents. So I've got two parents. They're still alive, but they're both retired, and they basically had the same job for their whole career. My dad worked as an aerospace engineer at Lockheed, and my mom was an elementary school teacher. And I don't know, it's funny, because the things I'm interested in are pretty similar. It's I'm interested in all the technical stuff, and I'm interested in the education. But I think, I didn't really learn that much of it directly from my parents. I didn't really learn, my mom didn't talk about, education. It was more a thing that she did, and my dad got me started on, with some books and some basic stuff on programming. He spent a lot of time just kind of teaching me some of the really basics of electronics, and then I got interested in it enough on my own to just get really deep into it. But yeah, it's weird, because my dad got me started with the engineering stuff, but we didn't really do that much of it together. He just got me started at an early age, and then we just went in our separate directions. And then I was never really that close with my mom. And I don't know, I don't really understand her strategies for teaching. I still have trouble with classroom learning, because it didn't work out at all for me, and so anything that even seems slightly authoritarian classroom stuff, I just don't want anything to do with that. And I think that's a lot of what the elementary schools turn out to be. How close can I focus? That's always the question with this lens. Coming up in a product change notification. Ah, cool. Yeah, this is an old part number, and so there's a document that says this will now be known as a CY7C63001A, which that's got to be one of their old easy USB controllers, right? I think this is what we're dealing with. So we had this number on the package, CP5549BMT. And then that cross-references with this number, CY7C63001A, which I got this datasheet for. And this is just one of the original easy USB style microcontrollers, I think. This says 8-bit RISC core, and I thought these were 8051s. Maybe not. USB optimized instruction set. So it's got a low-speed serial engine only. This has got to be an 8051. Why are they saying this is a USB optimized instruction set? These pin numbers are the way 8051's number I/O pins, and it could be something else, but... yeah, optimized for HID devices. A RISC architecture with 35 instructions. Whoa. So I'm familiar with a series of microcontrollers from Cypress called Easy USB. There was an original Easy USB, there was an Easy USB 2. The FX2, or like USB 2 line of Easy USB chips, I spent a decent amount of time with them. They're still relatively popular. If you just need to get a bunch of information back and forth between some piece of hardware and USB. They have some nice features, like a programmable state machine you can use to drive external peripherals. But there was another core which I used only like a little bit. I did like one tiny project with it, which was their earlier version. Like before USB 2, it was the like full speed version. But I was never really familiar with what came before that, and this has got to be the low-speed version of that core. But I would have assumed it would use an 8051, because the other two also use 8051s. And if you're not familiar with 8051, it's a very old, but also just extremely common microcontroller architecture. It's 8-bit, it has kind of a weird memory architecture where you have 256 bytes of fast access memory, and then another 16-bit address space. It's hard to write a C compiler for, but a lot of 8-bit designs still use it. So I would expect this to be an 8051, but the marketing copy here points to it maybe being something else. But a lot of people just trivially customize the 8051 and then call it something markety, because that's easy to do. Um, 128 bytes of data RAM, that sounds 8051-like. Data stack. Oh yeah, this is a different memory area. That's interesting. This is some really vintage USB hardware. Yeah, I'm gonna have to think about how to frame this. Because I mean, this is like the level of hardware complexity you do need to speak USB with any level of efficiency. I never used this chip, but in this same time period, the chip that I was familiar with was the PIC16C745. When did this one come out? Does this have a date, by the way? This chip? I also expected this to have the Easy USB branding, but maybe this came before that. This looks like 8051. This looks very 8051. One thing that I remember from the later Easy USB chips, at least, and I don't remember whether that would have been included here, but at least the stuff that I remember them really pushing with their Easy USB brand was how the chips included in silicon basically a very simple bootloader. So you could put them into a mode where they would answer certain control requests in hardware, and you could use that to bootstrap them. I don't know if these do that. Good old low-speed USB. Low-speed USB is signaled at 1.5 megabits, which is still kind of high as far as serial buses go if you're just trying to like write low-level code to bit bang it, but it is possible to bit bang this on like an AVR or anything pretty modern. You usually wouldn't want to, because usually you want clock recovery, and usually you want some hardware for that. Yeah, that's neat. This reference schematic, they have a 7.5K resistor, which is a pull down on D-, which indicates the device's speed. And then everything else is on chip. 6 megahertz resonator. Instruction set. This is 8051, isn't it? 3F20. This is 8051. Let's make me look up the 8051 opcodes. Oh gosh, they aren't 8051. Are these trivially rearranged? Oh no, this is actually a somewhat different instruction set. This is, yeah, geez, this is not quite 8051. This is a little bit more Z80-ish. What is this? X page. Oops. What is this? This is like, this is something I've seen before. But what? Or maybe it's just full of... This is like one of those movies where it's so generic you can't tell if you've seen it before or if you just saw the same, like, 10 movies that the person who wrote that was inspired by. They're using fairly big chunks of the space here for, like, an index instruction? What is that? It's just strange that they wouldn't let you know, like, oh, by the way, this instruction set is part of this family of things. The way they've presented it here, it's like I have no way of knowing whether this is specific to this individual part or not, and I'm certain it isn't. I'm certain it's part of some family. This just doesn't say what family that is. I'm just gonna Google for these instructions, though. Especially the weird ones, like IPRET is kind of a weird... I assume this is an interrupt return, but IPRET is kind of a weird name for an interrupt return. Xpage is something about memory paging, but it's also weird. Cypress Asm. Oh, is this its own thing? This was its own thing? Why was it its own thing? Oh, it's its own thing. The M8. The M8A and the M8B. So this is probably an M8B. I had no idea this was a thing. I thought Cypress started out using 8051 cores. I did not know that they developed their own weird thing and then stopped using it just to use the crusty... Like, the reason people use an 8051 core is so they don't have to go through the work of developing their own. I don't know, like, they must have just had enough pressure externally to use something that was more standard, even though 8051s are crusty and terrible. Or maybe, I don't know. I'm obviously just speculating here, but like the fact that they went through the trouble to make their own thing from 1998 through 2002 here and then switched to an 8051 is strange to me. But they wrote their own assembler and their own architecture. M8. Can I tell whether this is the M8A or B? It does look kind of like 8051, but the registers are different, and the encoding is very different, and it's got some different instructions. There's just this part of me that's in disbelief anytime I see an 8-bit architecture that isn't an 8051 or a PIC or an AVR. Just trying to see if I could tell which instructions are included only in the B version of the core, and then I could reference that with the list here. Product specification, page 11. Page 43. What are these product IDs even for? Oh, okay. 63001. Oh, this is a version A CPU. Wow. So this is the oldest 63 instruction custom weird thing that Cypress produced, and I have one right here in the hockey puck mouse. Hal says the last page has the CPU listings in which doc? Oh, do you mean this thing that I just found? Yeah. That's interesting. They started out with some smaller RAM parts at the beginning of their B CPU line. Man, is this the first chip that Cypress made with USB? This is the beginning of this product table, basically. How would I find that? And Cypress wasn't their original name. Like, this stuff was originally owned by someone else, and I'm blanking out on what that was. Like Anchor, was that it? Not the actual chip. CP. CP5549 BMT again. That still sounds like Cypress. Yeah, I don't know where I'd find a list of their early parts. It's like I kind of want like a catalog from their website from the ancient times. I'm curious what they have now, and then I'm curious what they have in the Wayback Machine. That's not gonna have legacy stuff. Is this gonna have legacy? I would not expect this to have deep legacy parts. USB 1 device family. the same change notifications I saw on Google. That's cool. That's a lot of cool information about the silicon process they're using. Thermosonic wire bonding. Oh, that's cool. They tell you how many devices were tested to get these figures. 4,197. Anyway, how interesting. So this includes the instruction set, which we now know is M8A, which is no longer, or wasn't even established enough for them to give it a name. The name was probably retroactive. This just seems like it was probably one of their first USB products. Just interrupt. I wonder if there's even a disassembler for this. Okay, let's try to figure out how the memory works on here. $4K of EEPROM. And it certainly seems like this was programmed by a supplier and then delivered with the code on it rather than being programmed in circuit. Like, I'm getting that from both the markings on the chip, and I don't see any in-circuit programming pads at all. There might be a USB in-circuit programming facility. Their later chips had that, but I don't know if this has that. There's probably a separate document for how the programming cycle works, so I might need to find that. We could also try to glitch out the firmware. I think yeah, I wonder how well that would work on a low-speed device. Huh. This is on some universal EEPROM programmers list. That's interesting. Huh. Oh, yeah, this is tagged as M8A in the knowledge base. That's useful. Where does that take us? If it ever loads. CY3652 development kit. Yeah, this might be one-time programmable EEPROM. Yeah. So it was probably programmed by the supplier. There probably isn't a way to program it over USB. The NCORE. It's the replacement. Wow, no external 6 MHz clock. That's neat. And combination USB PS2. Huh. No, we don't sell these anymore. Go away. Is this file still around? Yes. Both of those are listed as the user's guide, but that one's actually the disassembler. I doubt there's a disassembler. It's not like a lot of people would have reasons to be disassembling these ancient devices. But this is interesting. If this has some kind of definition for programming this. Yeah, where would that be on the pinout, for example? Instant on now. James, you're half right. Combo PS2 and USB is and was dead common, sure, but I don't know what you're talking about with 12 volts. What a simple and cute layout. High voltage programming. I can assume that's what this means, VPP. I don't know why else you'd have a pin like that. Ah, man, I wonder if that weird universal EEPROM thing that I have actually supports these. TL866 is what this is called. Ah, these are all just Cypress memory chips. I wonder if they probably wouldn't have made this compatible with anything else. I don't know why they would. It's probably something custom. Not a lot seems to be in the old name for BMT. How does the Loctite work? Oh. DigiKey. High-low programmer. Is that high and low voltage? I just need a high-low programmer, an adapter base, and a matrix card. Just those things. CY3649. Yeah, the datasheet doesn't have any programming information. I'm assuming that some other datasheet exists, but I don't know if that would be public. CY3649. Arrow. Oh, that's the same thing here. This is a converted PDF of a snapshot of the Cypress website from 2003. Oh, here's the programmer software. Already been there. Where do you get this? Center negative. Yeah. Oh, and of course it programs over RS-232. Oh man, it's looking like getting the firmware off of these things either involves doing some kind of glitch or other sort of interface that allows us to bypass having to actually go through the programming adapter, or we actually obtain a programming adapter somewhere, or we figure out how to emulate one, maybe by taking apart its firmware. The Cypress Start Kit. I seem to remember something like that for their newer parts. Oh, does this still exist? Oh. Does this still exist? Marketing projects. It's just an exe file. Yeah. So this was just a zip attached to this forum post, which could be anything. And so it's got this one exe file in it inside marketing/website/dev-kits. Like this would be a great place to hide a virus, right? Windows 3. Oh yeah, this might just be a Windows app. Is this a 16-bit Windows app? That would be fun. I don't think I've opened one of those in ages. It'd be really fun if this actually just had like parallel port bit bang programming. I kind of doubt it would. The interesting stuff is probably in the firmware for the USB programmer. Huh. And this is a small binary. So it's talking over serial port, as we'd expect. But I doubt this would include a copy of the firmware. Oh! This is where it's checking the firmware in the adapter, which is apparently running on an Atmel chip. I mean, not just any Atmel, but an Atmel 8051. They were clearly trying to make something which was not quite 8051. I kind of want to open this in IDA. Like, I don't really need to, I mean, I don't know. It might be kind of nice. I don't think we're going to learn enough about programming to actually be able to use the programmer, but who knows, maybe we'll get lucky. Maybe it'll be fun. SciStart.exe. What even is this? Is it a programming utility? It's probably a programming utility. Oh, okay, James explains that the 8051 stuff was in their acquisition of Anchor chips, and this was from before they bought Anchor chips, which explains why I've never seen it. I only knew of their post-Anchor chip stuff, and the stuff that I used was the stuff that they acquired, not the stuff that they built themselves, I guess. So here's our ancient Windows program. What happens if we run it? Is this a 16-bit app? File was telling me it was a 16-bit app, but I don't trust File, because File is very bad at these things. Let's just see what IDA thinks of it. So I'm just going to try to disassemble it as 32-bit NE. Really? Maybe this isn't 32-bit. So Windows 95 and later use PE files, which you're maybe familiar with. EXE is the DOS format. There was also COM, which was just like splatted into a segment in memory that you jump to. But then NE, I think, was Windows 3. Wow, it's 16-bit code. That is very 16-bit. And we have some symbols. Are those symbols? Oh, these are exports. I think these are numbered exports. I don't know if I've ever disassembled much Windows 3.1 code. I mean, I've done just like run it in a debugger and try to make sense of it, but I've never actually like opened it in IDA. So it looks like it also has annotated. Okay, so these are the exports from the binary. These are exported by number, which is a thing you can do. I don't know why they do that. And then these are like window message handler functions that you usually attach to a class that gets registered with the OS. Wow, so each of these correspond to like a UI dialog box, basically, and all the stuff that you might do in that dialog box. And then there's a main somewhere. Well, there's a start, which calls, oh, this is so old. There's a init task. I can't believe it's 16-bit. Oh my god, there's 16-bit addresses everywhere. These are function pointers. Oh no, these are args, which is saving. So there are saved registers up there. I was calling this. Anyway, let's look at the strings. We could look at the strings or the imports, but we already saw some juicy strings. Ah, Cypress Start Kit, USB programmer. So this is the part we care about, the 7C63001, which is in the mouse. Yeah, I'm interested in this one that says the internal source code of the AT93 or 89C9. The internal source code for the AT89C51 needs to be updated, and I think what it means there is the firmware. Oh, we have no cross-refs to that yet. Where would the cross-refs be hiding? So we could look nearby and try to further. Oh, because there's a lot of stuff here that we would expect to be used that isn't yet. Program WindProc and friends. So this is a big old thing. Here's the graph overview. I assume there's like a dialog box that's like for programming. Load cursor. This is going to be like an hourglass cursor thing. This is so old school. This is 16-bit desktop code. So like here's a printf. Where are we getting that from? So there's the output string. There's no, which order are these parameters in? There's the output string in DS. How does this I'm just not used to how this uses registers even. So, I mean, usually DS is data segment, and it points to the paragraph offset to the 16-byte boundary where you start referencing. I mean, and this gets blurry too, because x86 lets you define which segment you're using as your base for most indexing operations. But then there's like a default. So the data segment is like your default base for most kinds of data loads and stores. But it's also just a register that you can just use for stuff. Oh, right, that's a far pointer. So that is actually the data segment. So, oh gosh, I'm just figuring out how this works as I'm going. So here's a printf. Here's a bunch of printfs. So that's the output buffer, the combination of DX and so do I have to mark this as an offset? Oh, I do. Great. 16-bit offsets. So that's the... So AX is the output buffer. Is this... That's got to be the output buffer, and that's got to be the string, and then it just doesn't... Okay. And then that is the 32-bit integer in 2 pieces. Yes. So that's actually a D word. So, yeah, that makes sense. Yeah. 16-bit offsets are so weird. I'm never going to get used to these. Program, okay. User terminated. Verify, okay. So many juicy imports. So this is all user interface, and then this is the actual programming subroutine. And that does seem to write to this result code that we just identified. And this is using the exported functions too. Like, one reason to do this is if you want these to be usable as like an API from other programs. Now this has a loop in it. And it's doing more UI stuff. I wasn't sure if I would see like a clean separation between UI and backend, but not really sure why I would, I guess. And this uses the same printf buffer. It's probably in the same file. I assume these are status updates, like how many bytes we've programmed so far, maybe. I call this programming progress dword. Here we're zeroing it. Oh, or maybe that's, yeah, that's zeroed. So I guess this is also a UI wrapper and the actual stuff is done inside one of these functions. One B 6. This might be like a send command sort of thing that sends it to the underlying microcontroller. Anyway, I was curious about the firmware version thing. That would be an offset of 1 CD2. Like this one. These have got to just be write and read sort of things. Like we're doing some sequence of writes and reads or some other command sort of thing. And this is just writing the serial port. Yeah, so we could take this apart if we wanted to know how to talk to the firmware, but this firmware is actually what's implementing the protocol. And I don't think this includes a copy of the firmware for that chip. I mean, this isn't like it's giving you the option of doing the update, it's just saying nope. But now we know what the name of the chip is. I wonder if we can search for that at all. So that's the Cypress part number, the CY3649. And what if I just search for like hex file? That's probably going to be about the hex files you program into it. Maybe, oh, what was that chip again? AT89C51. That strikes out. What is this? It's just some kind of SEO garbage. It might be interesting to try to find one of these high-low programmers, but probably not that interesting. Even if we get the firmware out, there's not maybe that much to look at. Did I save this yet? Yeah, well. Yeah, I'll have to think about what else to do with this. So just to recap what we know so far, it looks like this device has probably one-time programmable EEPROM, which was programmed at the factory before being installed on the board, probably. And if we wanted to get the code off, we could probably figure out how to get it off using this M8 series programming interface, but it's not documented. We either need to reverse engineer it from the firmware or just like find one of these that we can buy. Probably not really worth it. It's interesting to know about the architecture though, and that's definitely some good background information that I'll want when I'm talking about this on a video. Well, it would be nice to get some oscilloscope traces of this. I still have not established whether the death of this thing was corrosion or a bad USB cable. This is weird. I was just noticing on this board, let's see, the package on both the transmitter and the receiver for the infrared light here, it looks like the receiver is backwards. It probably, I mean, I'm sure it isn't, but it's like the molding was done strangely on that case. Yeah, so the wheels go in these slots. The LEDs emit upwards, but it looks like they're hitting the back of this photodiode. The lens is on the top side, but the area it was hitting was that flat on the back. It's pretty weird. I wonder if it is hitting the back side and they're just relying on the bouncing internally inside the case there. That is strange. Well, I see a few different directions to go in. I could just kind of let this be and not go deeper into it. And maybe another thing that would be worth doing just before wrapping up this stream is just doing a basic teardown on these other two mice that I have here, to have some footage and some knowledge on just what microcontrollers are inside. So yeah, we know what's in here. We have data sheets. Not firmware, but I don't think I care about getting the firmware out of this thing. It seems like it's a pretty uninteresting low-speed USB device at this point. Yeah, so I need to think about what other shots to get as far as actually how to, like, I think now that I know just what technology to expect in here, I can plan out the video a bit more thoroughly, and then I can actually get some specific shots next time I have this thing open. Right now, I'm just trying to get an investigative sense of what's going on here. So I think it might be a good time to open these other two mice and do that kind of cursory level of investigation on them too. And this one will probably need some soldering too. Like, assuming it's not just completely dead, I might just solder some wires to that and use that as a, you know, just not use the cable, but see if this board's good. Alright. Put the USB analyzer aside, and what's next? Let's open the PS2 mouse and then save the serial mouse for last. This one is a bit more modern. Do we see any dates here? 06. So yeah, this one's from 2006. It's probably like 7 years newer than the mouse, the hockey puck mouse, even though this is PS2 instead of USB. So we might just see more optimized levels of manufacturing going on in here. It'll probably be nice to actually have a PS2 mouse around. I'm not sure I actually have any, and so there's occasionally some embedded thing that likes PS2 mice. It's nice to have at least one. Make sure I get some glamour shots of the plugs here. Not that there's much glamour to be had in this one. Maybe that angle. Thanks, auto exposure, keeping me on my toes. You can kind of see which pins actually have metal in them from that angle. Alright. Also a Logitech mouse. Much newer Logitech mouse. I think that might be the only screw necessary. Let's find out. Ah, there's a weight. That's just extra mass clipped in place. That's interesting seeing the wheel on the top. This wheel has the same kind of optical setup. You've got slots the light passes through. This one is definitely a single LED, but this is probably a similar arrangement with two photodetectors, which again I would assume are phototransistors, but could be diodes. LQ and LD are still the same designators they used, and I'm pretty sure LQ seems like it would be a phototransistor. And electrically, I would expect a phototransistor to be more useful here. Good little tack switches. That's the one for the wheel, which makes contact via this little arm. The springiness of the button is just the plastic bending. But that spring right there, I think that's for the indentations in the wheel. I think that's riding along little bumps on the inside of the wheel, providing the indentations. That's a nice design. So there are little bumps along the inside for the feel. There are slots on this side for the actual detection. You can see the slots are also really close to the photodetector. So it's like this is providing like uniform illumination at a distance, and then the shadow that this casts just sweeps across the photodetector. Oh, I was expecting this to be a single chip. That's interesting that the optical sensor is separate. So because this is such a new mouse, relatively speaking, I would expect this to have no programmable components. This is probably a mask ROM microcontroller of some sort. And then that's the ASIC just doing the optical flow. That's interesting. Let's see what this looks like on the USB analyzer, actually. Oh, never mind, this isn't USB. This is PS2. Actually, PS2 is simple enough. I don't know if this is even a mask ROM micro. It might be just an ASIC. So this is probably speaking SPI or something similar between the two chips. It would potentially be interesting to take a look at that on the scope. There's the lens. If you buy one of these optical sensors, they send you this thing, and that thing, and that thing, and you design your plastic parts around it and your board around it. Yeah, so James is also bringing up that it might support USB internally, like it might be new enough that they had USB support in here. Yeah, maybe. A lot of these, especially from Logitech, had an adapter where you'd plug this into a little dongle, which had a USB plug on it, and it just repurposed the data and clock lines as D+ and D-. I don't know if this one supports that feature, but it's possible. So it looks like those two thin traces are data and clock from the sensor, maybe. Maybe that one too. I think that's probably a transistor for turning the LED over here on and off. That's what that resistor is for. Mombasa PS2. I would expect... So, I don't know. I mean, the multi-protocol ones I'm aware of from Logitech, actually, now that I think about it. The cable was USB because they needed the twisted pair. And then they had a USB to PS2 adapter rather than it being the other way around. I thought that when I looked for this, I was trying to find one that only did PS2. Is that an Agilent logo on the chip? Anyway, A2610. Yeah, it's an Agilent ADNS 2610 optical mouse sensor. Optical navigation technology. This is a little bit old school. More modern mice have a single chip that does this and talks to the PC. And this is SPI. That's cool. Oh, that's cool. So you can get not only the stuff you'd expect, like X and Y, but you can get a surface quality metric, which is cool. Maximum pixel sum, the actual image from the pixel sensor. Oh, that's cool. Example images. That's great. These are good little sensors. I think the Parallax Breakout used a similar sensor. What about this processor? I mean, it might not be a processor, but it's probably a processor. Huh. That looks like pin 1 is reset, and that's power. That's 16 pins. That's 36, 1, 3, 3, 9. So yeah, it's got a bunch of markings here. It's copyright Logitech. Then I think that says 361339-A000, and then RTH0011. And the bottom line where you'd find date codes and stuff would be 6634. Let's do this under the microscope. I can almost do that. Oh. 66346QI. Oh, 1. Interesting. L25. RTH0011 is showing some hits on optical mouse datasheets. Can't tell. I mean, these are just coming from like alldatasheet.com and junk like that. Yeah, like I'll search for this number 361-335-A000 and somebody will be like, this is a Logitech part number, but have no additional information about it. Oh, did I just find something in Russian? Oh, this is just somebody on an electronics forum trying to understand how mice work. Don't think this is relevant, but this is like somebody's ADNS 5050. This might even be from a like Agilent's datasheet. This also looks like an 8051, right? I don't know what kind of processor this is. Well, that's interesting. We might have to put this aside and try to, I don't know. Like, I only sort of care about knowing what processor's in here. Whoa, 24 megahertz? I don't know why it would need to be 24 megahertz if this was a PS2 mouse. Maybe this does support USB. Oh, hey, Tej. It was cool to catch in your stream earlier today. Yeah, I guess it's possible that this is dual protocol, and it's even possible this is another Cypress, like M8 chip. Because I don't know, it does have that sort of weird scheme, but I don't know. It could be a lot of things. Yeah, we could try hooking it up over USB. That might be interesting. It just needs power and ground and 2 wires. Let's open up that serial mouse first, but I think I need a restroom break, so I will be right back. I have a whole little family tree of different vintages of mouse technologies here in a sec. How many pins does this have? I'm assuming 18 or 20, because a 17-pin chip would be pretty weird. Sorry, this is what I was looking at. Oh! Right, the 24 megahertz is connected to the sensor, not the micro. So I guess it's just a coincidence that that would also make a great frequency for USB. Oh yeah, the part number. Yeah, so this is the mystery microcontroller. Logitech 361335-A000. I don't know if that's a micro or like a firmware identifier. And then RTH0011. And then the bottom line is 66346Q1 space L625. Yeah, that's weird. I would have expected maybe RTH0011 would be the type of microcontroller, and then that first number would be something customer specific, but I don't really know. Okay, let's come back to that. Let's crack open this vintage serial mouse next. So this is the one that I probably spent the most time with out of all of these. Like, I've certainly had mice kind of like this particular Logitech one. I had some of their USB mice for a long time, and my school had some of these hockey puck mice for a while. But I think my dad had one of these, and so I spent a lot of time with this mouse. Quite a serial number. Yeah, so I saw folks like listing the IC for sale, but I didn't see information about it. I didn't see them on Alibaba though, I saw them on like stuff that's more spammy than that, so I don't know. This is a little stuck. Oh, what horrors wait for me under here. Oh. Oh, there we go. Feels like there's a screw, and there's a screw. Alright, autofocus. See how cleanly I can get this off. Ah, there's like a clear layer that's coming up without the rest of the sticker. There we go. That's getting there. Smells like isopropanol in the morning. This technique does take a risk with the ink on the sticker, but I don't care that much. These are not really rare at all. These were like the most common mouse for a long time. Aw, well, thanks for trying, Hedge. Hedge reports there's nothing on the Taiwanese or Chinese Googles, I think. There's like something kind of flaking off of this onto my fingers. Okay. It's probably not going to be sticky when I need to put it back on. but whatever. It's so clean under there, wow. That's how you retro bright, am I right? Looks like this comes off topways. There's a weird little doodad here above the cable. That clips the cable into the bottom side. I don't think I need to take that out. Oh man, it smells like isopropanol and old electronics. Maybe it's like fermented cigarette smoke or something from the 80s. It feels like there's something specific I need to do here to get it apart. I could definitely get it apart by just pulling, but I might break it. Yeah, it looks like there might be a screw right here, but I don't see how you get in there. It also looks like you might just like wedge something in between this and the cable, but then I don't want to ding up the cable. Oh, that worked. I guess it was just a snap. I guess I could have put something thin in between there to pull the snap out more gently. I don't think I broke it though. Wow. This has definitely had stuff spilled in it. I mean, some of that might be the isopropanol, obviously, but it smells like there's something else too. So, Mitsumi MSO2. Huh, C339. So that capacitor and the diode might be related to power storage. I mean, there's also all these capacitors. So I'm expecting to see a microcontroller or something, like an ASIC, but probably a microcontroller. And, oh, metal wheels. And then some hardware for extracting power from the serial port, and then some kind of serial line driver, which might just be transistor, might be something more, but it might just be a transistor. Yeah, the metal discs are really unusual. They don't move very well right now, but it's not terrible. Whoa, neat. Ryan found someone's hardware hack to turn this into an Amiga mouse. That's pretty cool. wiggling. Alright. Oh, that's one of the better illustrations I've had so far of these encoder wheels working properly. It's really dirty though. I know I'm just mostly blowing the dirt onto the circuit board, but you can see less of it now. Yeah, it's probably like cigarette smoking soda or something. All that shiny stuff is not alcohol. That's not evaporating when I blow it out. I think that's probably soda or something like that. Booze. Ooh, nice. Ryan says that page has pinouts too. Yeah, let's look at that in a sec. It's a little slippy. I'm also not using this on a proper vintage mouse pad, which is maybe part of the problem. This would be fun in 60 frames a second, which my camera doesn't film in, so I just have to move it really slow and then speed it up 2x. I should maybe think about upgrading this camera. I mean, I have been thinking about it, but not enough to like pick a particular like style of camera or brand even. I mean, I'm thinking something that can do 4K, 60 fps, and probably something mirrorless. Maybe even something that's actually sold as a video camera instead of a DSLR. Because I do use this one more for video these days than stills. Alright, let's put the photography aside for a second, take a look at this link that Ryan's dropped on us. Whoa, it's a good old-fashioned text file. Cool. Huh, removing a chip and adding 2 resistors. Oh, interesting. So the Amiga mouse was very simple. It was just connected directly to the optical encoders. So this mouse hack was basically just bypassing that, the micro in there. Oh wait, was that an actual comparator? Oh yeah! Wow, yeah, that chip labeled C339 is an LM339 comparator. Wow, I did not expect it to be that low level, but here we are. So I assume that MS02 chip is very application specific, because this is a Mitsumi mouse. I assume MS is like either Microsoft or mouse. Oh, and so the LM339s were common in these vintage mice, I guess. Interesting. So that would be the Zener diode for the current or for voltage limiting. And the emitter LEDs are powered directly by the recovered higher voltage from the serial port. I'm curious about the firmware on this thing? Oh. Just that. And this? Somebody else's mouse, okay. I don't know why James needs to troll my channel. It's like, why should I be more into Canon? I mean, Canons are fine, but it's not like I think that their video cameras are gonna be like especially awesome or anything. Why would I have brand loyalty at this point? Oh yeah, Sean says it's like the smell of an old CB radio microphone handset, the smell of the 80s. Yeah, it does smell very 80s. I don't know how else to communicate it, I guess. Some combination of airborne contaminants that would have been popular then, I guess. Alright, can we get this out? That's screwed in 2 places. Doing this and getting it on camera are 2 different things. I mean, I find the flame war stuff weird where people are like, I want Vi and I want Canon and no, I'm a Sony person, and that's a terrible thought. But it's like weird when people like want to stoke that for fun, which seems to be a thing. Do I have to take the mouse out? Or the mouse ball out? Oh no, it's just a little crusty. It's just a tight fit around those 2 posts. I might as well have taken the mouse ball out. It just hangs out there. This is one of the few mice you could actually pretty much use without the enclosure. Cute little quadrature wheels. Yeah, and more surface mount than I expected. I kind of figured that was it, and it has a few links here, but not a lot. And then on the back side, it's just resistor town. Even my hands smell like it after handling it. It's like some kind of electronics manufacturer byproduct. Like some of it might be flux. Some of it might be stuff that was spilled on it. I don't know. So you can see the emitter with 2 pins and the detector with 3 pins. Weird little ground bus there. That one little strip that has no solder mask over it. Yeah, this thing is definitely built like a brick. This is one of the more overbuilt things that I've taken apart recently. It just seems like it could be much simpler like the newer Logitech mouse, but it had all these separate pieces because they were still developing it. Little solder bumps there that spell out 9. Definitely not a completely purpose-built chip, right? Otherwise, why would they be doing this weird stuff here? This is a group of 2 pins tied to each other and then pulled down. Another group of 2 pins tied to each other and pulled down. That's a little strange. And that might be the serial output. Thing that's connected to a transistor and then maybe driving that pin on the left. Yeah, maybe. Yeah, that's really weird, isn't it? I don't know how I would even start to find that. I'd have to I guess I'd just be looking through like what microchips would they have even had access to in this vintage? Like what was Mitsumi making as far as I assume was Mitsumi making microcontrollers or is this something rebranded? I guess that's the first question. Oh. Yeah, Mitsumi does make something called the MN101, which is an 8-bit micro. That's like a current product though. What about historical stuff? All the stuff on the current Mitsumi Panasonic website is MN101 and MN103 and stuff like that. Panasonic.com wants to show me pop-up ads. No. Ryan says that date code might be 1992. Yeah, maybe. There's something else from Mitsumi called the M282N. That's a motor. What does DigiKey have? There must not be that much ROM space, but wouldn't it be strange if there were undocumented commands like in that firmware? Be an interesting thing to discover. Probably not that useful, but I would be interested by it. Anyway, I think we're out of stuff to investigate on this stream. I think that was interesting. I'll keep this around for future experimentation, but yeah, I mean, I think the reason to have this right now is as a kind of visual aid and comparison point for this USB video, but it would also be something to keep in the back of my mind, or our minds, thinking about how it could be repurposed interestingly. I'm also thinking, like, oh, could you find, just as it runs, could you find interesting noise on the power line that correlates with how it's running, and would that be interesting to look at all? Yeah, so I'll think about what to do next with these, and do all the other stuff that I need to do for this project, like outlines and scripts mostly. But this was an interesting tidbit that should be, maybe useful for that project. Alright, I think that's it for now. I'm going to keep the cat stream going as long as Tuco continues to be on camera. I guess that was over here. Yeah. So if you want to hang out with Tuke, you can head over to Tuco, or sorry, not tuco.tv, that would be a thing, but twitch.tv/TucoFlyer, and you can just keep an eye on the cat as he sleeps, I guess. But yeah, in the meantime, I think I will go back to doing some other stuff until I have some content that is worthy of a stream. And yeah, thanks for hanging out. As usual, I really appreciate it when folks hang out and tell their friends about the stream and just generally contribute their enthusiasm and knowledge and questions. And yeah, that's all been great. And a special thanks to everyone who keeps the stream going and keeps the edited videos coming with their donations of parts and money every month. That's what helps me keep living and working here and providing the content that I can for all of you. So I'll keep that up, and I'll keep the streams coming, and I usually announce these ahead of time if I have the plans ahead of time enough on Twitter. And I've asked folks in the past, whether that's kind of spontaneous streams or more kind of pre-planned streams are better, and usually folks lean toward the spontaneity, but let me know what you think. I might try to do something where I have like a weekly time slot, but then also spontaneous streams, depending on how much content there is. And with that, I'll see you all next time. Happy hacking.